In section 1.4, we're going to take a look at classifying and measuring angles and then also angle addition postulate. So for angles, most of this should be review, but for an angle, it's just two rays that share a common initial point. So remember that starting point. If you look at this picture here, B is the common initial point. So we've got ray BA on the side here, and I'm just going to write that down so you can see the name for this side. So this side is ray BA. And then this ray over here is ray BC. So then together they just form this angle, which is this kind of rotation from one ray to the next. This is the angle. So when we name an angle, there's a few ways to name an angle. So one of the ways that always should work is naming it by three letters. So when you name it by three letters, this common initial point called the vertex needs to be the middle of the three letters you use, okay, because it is the turning point of your angle. So when you name the letters, if I were to trace the angle with my fingers following the letters you told me, that should draw that angle. Okay, so A, B, C. So you put B in the middle, one letter from either side of the angle then. So A, B, C, B being in the middle, A being on one side, C being on the other. That's one way to name an angle. Another way is to use the vertex. Now, the only time you can do this is when it's the only angle that possibly has that. So the way my picture is here, it's the only angle available. So I can call this angle B. And notice we put a little picture of an angle in front, just like we did for segments, put the segment above it. So I can call this angle B because there's no other angles possible that have vertex B. Totally fine. Sometimes you'll also see a number on the inner part of the angle. So then you can call it by its number. So angle 1. Now be careful because we'll also be measuring angles. So you may see numbers in here that's to be a degree mark or the measure of the angle. So make sure there's no little degree mark. So for instance, if this one said 40 degrees in it, that's not the angle number, that's the measure of the angle. Okay, so naming it in those three different ways, make sure you put a little angle in front of it and use one of those. This should all be review. So an acute angle is just an angle that's between 0 degrees and 90 degrees. Just draw yourself an example. So something smaller than a 90-degree angle. For a right angle is exactly 90 degrees. Make sure you put this little box in here to show that it's 90 degrees. Okay, so if you're drawing a right angle, you have to have that little box in there to tell that it is exactly 90 degrees. This is the marking that tells us. Without it, it's not a 90-degree angle. Obtuse angle needs to be bigger than 90 degrees, but less than 180. 180 being a straight line or a straight angle. Okay, so we've got this tiny little angle as acute. We've got the 90-degree angle. We've got this one bigger than 90 at obtuse, and then this one equal to 180 for a straight angle. Angle bisector, so we talked about bisect a couple lessons ago. So remember, bisect just means split into equal pieces. So that means that this side of the angle and this side of the angle are identical in measure. So if this one is 30 degrees, this one is 30 degrees. This little arc here is called an arc mark. So it's like a tick mark, and it just means that those sides are congruent. So if you ever see that on a diagram, it means that those angles are congruent. So algebraically speaking, when we go to set up formulas for this, when you see the word bisect, it means piece equals piece. So you'll be setting those two pieces equal to each other. Again, geometry always is like trying to set up equations. So versus thinking that bisect means cuts in half, which it does, that doesn't give us an equation. So it's nice to think of it as bisecting splits into equal pieces. Angle addition postulate is much like the segment addition postulate. So you're going to have this whole angle. So this is just a lot of words. and letters to tell you that these two pieces will total the whole angle. Okay, so remember for segment addition, we said piece plus piece equals whole. Same thing for angle addition. Okay, so it's just those little pieces. So this little red angle right here, okay, and we put a little m in front of it when we're talking about the measure of it. So this is measure of angle RSP. Okay, so this angle here, plus the measure of this angle, PST, is going to equal that whole bigger angle, RST. So again, it's just piece plus piece equals whole. So these two smaller angles added together equal the bigger one. So let's take a look at a couple examples here. So given, and now you're going to have to make sure you can find this angle. So again, given the measure of MAR, so let's take a look. So MAR, so when you go to the diagram, just put your finger on here and follow from M to A to R. That's the angle we're talking about. So MAR is this whole angle. So this whole angle is 124 degrees. Now it says find the value of X. So we're going to write an equation here to put these together, because we see this chunk over here for angle MAC, or CAM, you can go backwards, and then this 4x minus 25 for angle CAR. So piece plus piece equals the whole angle. So one of the pieces is 6x minus 11, so that's this angle right here. Then the other piece is here. So this is 4x minus 25. And then that totals our whole angle. Notice how this whole chunk was filled in by those two angles of 124. So we'll just go ahead and combine like terms here. So we've got the 6x and the positive 4x to give us 10x. Then we've got negative 11 and negative 25 for negative 36. So we'll go ahead and finish solving this. So we've got two terms over here and one over here. So which of these two, 10x or negative 36, is a like term with 24? And it's the negative 36. So we'll add 36 to both sides to get the 10x by itself, because negative 36 and positive 36 is 0. 124 plus 36 is 160. Divide by 10 to get x by itself, and we will get x equals 16. So we just want to go up and make sure that we did what the problem asked, and in this case all it said was to find the value of x, so we are good to go. We don't have to do any more. You always can plug x back in to make sure that you did the problem correctly. So if you do 6 times 16 minus 11, you'd get 85 for this angle. And if you do 4 times 16 minus 25, you would get 39 for this angle. And then just quick check, 85 plus 39, is that 124? It is. So then you are have a very good indicator that you did the problem correctly. So that's angle addition, just very similar to segment addition. So then when we get into measuring angles, okay, so measuring angles, you are using a protractor. So I've got a protractor here. You've got this little hole in the protractor if you're using a physical protractor versus one online. That needs to go on the vertex of the angle. So we're going to move this onto the vertex of the angle. then this dotted line needs to line up with one of your sides, okay? And now my 0 degree is right here, so I'm gonna line that up with this side. So that's my 0 degree is starting on that side. So then make sure you're on the vertex and that your 0 is lined up. And then you can measure how big this angle is. So 10, 20, 30, 40, all the way to 90, 91, 92, 93 degrees. So you're measuring from here all the way over, following from 0 up to that angle. So then we see 93 degrees for that one. And then if you needed to classify this, this is an obtuse angle since it is bigger than 90 degrees. So now this one says, given straight angle ABC, use the protractor to measure angle ABD. So ABD is this one. So ABD here, if I follow it with my pen, so that's that angle. So ABD is this one. And then it also wants me to measure angle CBD. So CBD is here, this bigger angle, this obtuse angle. So I want to measure both of those. So we'll go ahead, we'll put the protractor on the vertex. Okay, so now it depends which one you want to measure first. So I am just going to straighten this out, put it back on the vertex. So remember I said you can start at 0. Well, when I'm measuring this green angle, I didn't want to rotate this all the way around. You can, if you want to, rotate this all the way around and do it this way to get that 0 on there. I just didn't particularly want to. So one thing you can do here is, let me line this back up. So one thing you can do, again, just make sure the center is on the vertex. Then you can go ahead and so it starts at 180. So now I'm just going to count backwards. Okay, so for this angle, it actually the way I have the protractor, this is 180. Okay, this is going 10, 20, 30, 31, 32, 33, 34 degrees. Okay, so you can just count backwards that way instead of actually looking at the number here, which is going from 0 to that. So we got 34 for that angle ABD. And then CBD, so again, now that one I have lined up at 0. So I have one side of this angle lined up at 0, and I just want to go out to the next one, 0 all the way over. So 0 up to 140, 145, 146 here. And then it wants me to add those two together. So just doing 34 plus 146, whoops, which is 180, which hopefully makes sense because if you look at this, it's a straight line. So that whole thing, if I went from start to finish, is 180 degrees. So that should happen there. All right, last one here. You're shown angle GHI below. So GHI, so let me move this out of here. So GHI is this angle whose measure is 52 degrees. Okay, so they told you that it's 52 degrees, and you can see that here when I set the protractor on here, 0 up to 52. Wants us to draw an angle bisector. So angle bisector, which is going to split this into 2 equal pieces, okay, by clicking and dragging a ray out of vertex H. So if I just get a ray here, so out of here, then I'm just going to draw an angle bisector. So in order to figure out how the 2 pieces would be equal, how big each one is, take 52, divide it by 2, and you get 26. So then you're going to want to go from 0, 10, 20, 25, 26, and draw that ray right down the middle. Then this particular question is asking us which of the following of these is true. So measure GHI. So GHI, oops, I forgot to label. This one told us to draw that ray as HJ. So just label a point out here as J. So this one says GHJ is half of IHJ. So GHJ is this one. Is that half of IHJ? So IHJ is here. Well, that's not half. Those are the same. Those are the angle bisectors. So that one is not true. Next one, half of GHJ. So GHJ is right here. So half of this. Remember, this is 26. So half of 26, same 13 there, is equal to IHJ. So IHJ right here, that's the other piece that's 26. So is half of 26 equal to 26? No. So then so the next one, GHI. So GHI is this whole big angle here, that's 52, is equal to IHJ. So IHJ right here is 26, so that's not true. So hopefully this last one is true. So GHI, this big angle, 52, is equal to 2 of IHJ. So IHJ is this one. If we follow those letters, this one is 26. So is 52 equal to 2 times 26? Yes. So then this would be our true answer here.